I am building a Rust AI agents framework focused on privacy, reliability, and zero bloat. Most agent frameworks feel slow and fragile. I'm designing one to run fast on real devices. I want to bring software back to a time when it just worked and it was enjoyable to use. When elegant engineering wasn't a luxury, it was the default. Today, I'll show you the architecture behind it, the system that will eventually power Project X. Welcome to another video in my crazy adventure. Today, we will look at how I design my AI agents framework. At the end of the video, I will start unboxing the first two pieces of the puzzle that will be my home lab. A lot of frameworks optimize for chaining calls in one process. Great for demos, rough for devices. They suffer from chatbot latency and are mostly designed for web applications. Also, they are hardware blind as they are mostly optimized for cloud. Nevertheless, there are some great concepts that are worth exploring, like the graph capabilities of LangGraph and the inter-agent messaging system of AutoGen. This is what will power Project X. The main ideas and values I want to instill in this framework are bulletproof by design, meaning reliable and robust, easy to extend, easy to maintain. Privacy first. User can choose between running the framework using local agents or cloud agents. Zero bloat. Stay away from dependency hell to achieve memory efficiency and quick, easy installation process. Elegant code. The least amount of code to solve a problem, which also provides speed. Hardware awareness. To improve performance, we will not just treat agents as glorified function calls, but as entities that are aware of the hardware they perform on and optimize for that. Everything starts at the edge. A device sends a request. The API layer does the boring but critical part: validation, normalization, and turning the raw input into a clean HUD request. HUD request is the boundary. After this point, the system doesn't care if the input came from a phone, a wearable, or a script. From there, we enter the orchestrator. This is the gatekeeper. It owns the run, sets up context, chooses the right graph, and makes sure the whole execution stays predictable. This is also where reliability starts. One entry point, one place to enforce rules. The core idea is a graph. A graph is just nodes and edges, but it gives you something most agent frameworks don't have: structure. In the middle of the graph sits the agent abstraction. It's intentionally small. Given context and input, produce an output or an error. Now the framework moves information as messages. Agent message is the unit of communication. Who sent it, what it contains, and how it flows. Message payload is where we hold the actual content: text, images, tool outputs, and for heavy data we store it once and pass references. That keeps memory predictable and keeps things fast. At the top answer is the final structured result. I'm building the lab like a puzzle. One new piece at the end of each video. Today, it's the mat and the soldering kit. Soon, we start learning the basics of electronics and actually building hardware. If this architecture resonates, subscribe for the build logs and comment contrib if you want to join when the repo opens. Next video, the exact Markdown and Visual Studio Code system I use to learn fast and not forget anything. For daily progress logs, follow me on X. See you next week.